Hey guys, today we are going to solve some rational equations. Some of these are going to get pretty complicated. I'm going to show you two different ways to solve a simple one here. Now, one thing we could do is find a common denominator and add these together. So in order to do that, we would multiply top and bottom here by 2 and top and bottom here by 3. So we would get 2x over 6 plus 3x over 6 equals 7. So now I can combine these because they have a common denominator. So that's 5x over 6 equals 7. And I can multiply both sides by 6, and I would get 5x equals 42. And then I would divide by 5, and 42 over 5, I don't think that even simplifies. So x equals 42 fifths. Okay, now same equation, but in a different way. Okay, so what I could do is multiply this entire equation by the factors of the denominators. So I have a factor of 3 and a factor of 2. And I will distribute the 3 and the 2. When I distribute here, the 3 cancels. So all I have to multiply by is 2. So I have 2x. When I distribute here, the 2 cancels. Okay, so I just have 3 times x, so that's plus 3x. And when I distribute here, I have 3 times 2 times 7. So let's plug that in a calculator here. 3 times 2, let me turn it on first. 3 times 2 times 7 is 42. Okay, so I can combine like terms, and I get 5x equals 42. And I divide, and I get x equals 42 fifths. Okay, now on a simple one like this, I'm not so sure that one method is a whole lot simpler than the other. But this method right here, when these get more complicated, this will be a much simpler lesson or much simpler method for you to use. So we're going to use this method throughout the rest of this lesson. Now we're going to solve some rational equations using the second method that we just used in the opener, where we're going to multiply both sides by the least common denominator. And really we'll just be able to do that by multiplying by the factors of all the denominators. So here, the least common denominator is just this single m that's down here in this denominator. So that's the only factor I find in any denominators. So I'm going to multiply this entire equation by m. So when I distribute here, the m's cancel. So I have nothing left to multiply by, so I have 15. When I distribute here, there's nothing canceling, so I have m squared. And then here, there's nothing that cancels, so I have 8m. And then here, nothing cancels, so I have 10m. Okay? Now, when I have an m squared and an m, it's best to just get everything to one side. So we have 0 equals, and I'm going to move everything to the other side, to the right side, because my squared term is negative, and I want that to be positive. So I'm going to have positive m squared on the right side. Then I have 10m minus 8m, so that's 2m. And then I'll move this 15 over and have negative 15. Okay, so let's see if we can factor this. So we've got a lead coefficient of 1, so we're just trying to find two numbers that multiply to negative 15 and add up to 2. Okay, so if I can just find two numbers that multiply to positive 15, then I can play with the signs. So how about 3 and 5? 3 times 5 is 15. I need one of them to be negative so that it multiplies to negative 15. So if I make the 3 negative, so I've got 5 and negative 3, they multiply to negative 15, they add up to 2, so I get 0 equals m plus 5 times m minus 3. Okay, so then I can set each factor equal to 0. M plus 5 equals 0. So to make this factor equal 0, it would take a negative 5. So m equals negative 5. And to make this factor equal 0 would take a positive 3. So m also equals 3. Okay, now before I put a box around this, I need to check the domain. So we always want to check the domain when we have a rational equation. So in this case, I have an m in a denominator, and if my denominator here is 0, then I get a non-real number, I get an undefined number. So m cannot be 0. Now my solutions are -5 and 3, so those are both okay. If I had a solution that was 0, I would have to throw that out because that would give me an undefined term. Okay, so let's just check this domain right away. So what can b not equal? So if I put a 3 here or here, 3 minus 3 would give me 0 for a denominator, and that gives me undefined term. So b cannot be 3. If I put a 0 in for b, then this denominator would be 0. So b cannot be 0 either. So if I get solutions that are 3 or 0, I've got to throw those solutions out. Okay, so the factors of the denominators are b and b minus 3. So I'm going to multiply by b and b minus 3. So when I distribute here, b minus 3 will cancel. So I'm still multiplying by b. So I have 4 times b. Okay, when I distribute here, the b cancels. But I'm still multiplying by b minus 3, so I have 3 times b minus 3. Okay, then when I distribute here, b minus 3 cancels, so I need to multiply by b, so I have 2b times b. Okay, so I'll distribute and then multiply these, so I get 4b plus 3b minus 9 equals negative 2b squared. Okay, so let's move this over to the other side and get a positive lead coefficient. So I have 2b squared plus 7b minus 9 equals 0. Okay, now let's try to factor this one. So I have a 2 for a lead coefficient, not a 1. So I need to do 2 times -9, and that is -18. So I need two numbers that multiply to -18 and add up to 7. Okay, so if I can find any numbers that multiply to 18, how about 2 and 9? 2 times 9. Can I make one of those negative, so it multiplies to a negative and adds to 7? How about 9 and -2? 9 times -2 is -18. 9 plus -2 is 7. Okay, so I'm going to split this 7b into a 9b minus 2b. So I have 2b squared, and then the 7b becomes 9b minus 2b. Okay, so now I've not changed the value at all. I just changed this 7 into 9 minus 2, and now I can factor by grouping. So when I group these first two, I can factor out a b out of both terms. So if I divide both of these by b, I get b times 2b plus 9. From this second group, I can factor out a -1. And when I divide both by -1, I get -1 times b plus 9. I'm sorry, 2b plus 9 equals 0. Okay, so now both of these two terms have a 2b plus 9. I can pull that out, so I get 2b plus 9 times b minus 1 equals 0. So there's my factored form. So now I can set both factors equal to 0. 2b plus 9 equals 0, and b minus 1 equals 0. So here I have 2b equals -9, so b equals -9 halves. And that does not violate the domain, so it's not a 3 or a 0, so I can keep that. And here I get b equals 1, and that's not a 3 or 0 either, so I get to keep both of those. Remember to check that domain though. If I get a number that violates the domain, then I would get undefined terms and I have to throw that solution out. So on this next one, we have two different factors in the denominator. We have 2a plus 1 and 2a minus 1. Okay, and that is a pair of conjugates. You may remember that word. They're almost the same binomial, but one has a plus, one has a minus. When I distribute here, 2a plus 1 cancels. So it's 3a times 2a minus 1. Okay, then we have minus 4, and when I distribute here, 2a minus 1 cancels. So I'm multiplying by 2a plus 1. And that equals 1 times, and nothing cancels here because I have no denominator, 2a plus 1 times 2a minus 1. Okay, so now I'll start distributing. I have 6a squared minus 3a minus 8a minus 4 equals 4a squared minus 2a plus 2a. And those cancel. Minus 1. Okay, so let's bring this 4a squared over to the left and this minus 1 over to the left. So I have 6a squared minus 4a squared. That is 2a squared. Negative 3a minus 8a is minus 11a. Okay, then negative 4 plus 1 is negative 3. Okay, so I could factor this. So let's see, I've got a lead coefficient of 2, and 2 times negative 3 is negative 6. And I have to have numbers that add to negative 11. So I've got 6 times 1, and if I make one of those negative, I can't make those add to negative 11. I have 2 times 3. If I make one of those negative, they won't add to negative 11. So it looks like I won't be able to factor this one. So our other options are completing the square or the quadratic formula. So let's use the quadratic formula. So I have A equals opposite of B, which is 11, plus or minus the square root of B squared, negative 11 squared, minus 4 times A, which is 2, times C, which is negative 3, all over 2A, and A is 2. Okay, so I've got 11 plus or minus the square root of, and let's just type this all in a calculator here. Negative 11 squared is 121. Minus 4 times 2 times negative 3 is 145. Okay, and that's all over 4. Okay, so let's see if we can simplify this 145. So the square root of 145 is the same as the square root of 5 times, so let's see, divided by 5, and I get 29. And those are two prime numbers, so it looks like the square root of 145 cannot be simplified. So this is my final answer for A. Okay, now we do actually need to check the domain though. So 2 times what plus 1 equals 0. So I'm just going to set each denominator equal to 0. I'll do this down here. So 2a plus 1 equals 0, and 2a minus 1 equals 0. And we'll find out what the denominators cannot be. What makes these denominators equal 0? So I get 2a is negative 1, so a is negative 1/2. And 2a is 1, so a is 1/2. So I can't have answers of plus or minus 1/2. This is not 1/2, it's not negative 1/2, so it is okay to keep this solution. Okay, so this time I have 3 different factors to multiply by. I have a 2, I have a 3, and I have an n. Okay, I could do 2n, 3n, and n, but that's just going to make this really messy. So it's going to be easier if I do just 2, 3, and n. So when I distribute here, the 2 and n cancel. So all I have left is 3, so it's 1 times 3. When I distribute here, the 3 and n cancel, so all I have is 2. So it's 2 times 6n minus 9, which is 12n minus 18. When I distribute here, the n cancels. So I have 2 and 3. So it's 2 times 3 times 2, which is 12. Okay? Now, what can my solution not be? 3 times 0 is 0. 2 times 0 is 0. 3 times 0 is 0. And a 0 here would give me an undefined or an undefined term. So n cannot be 0. Okay, so if I get 0 as a solution, I have to throw it out. So I'm going to move over this 18 and this 3, and I get 12n equals. So then I have 12 plus 18 minus 3, and that is 27. Okay, and then when I divide, I get n equals 27 twelfths. Okay, now that can be simplified. 3 goes into both of those, so n is 9 fourths. And that's not 0, so I may keep it. Okay, number 5. So on this one, I have an x plus 7. Okay, but I also have an x squared plus 7x. And I could write that here, but I think it would be easier if I actually factor this denominator. I can factor a GCF out of these two terms. The greatest common factor of these two terms is x. And that leaves me with x plus 7. And look, I've already got an x plus 7 here. The only thing I don't have here is this x. So I'll distribute x times x plus 7. So I distribute that here and nothing cancels. So I get x times x plus 7, which is x squared plus 7x. I distribute here and everything cancels. So I have nothing left to multiply by. So I have minus 5. And when I distribute here, x plus 7 cancels. So all I have left is an x. So I have 3x. Okay, so I'll move this 3x over, and I get x squared plus 4x minus 5 equals 0. Okay, so I have a lead coefficient of 1 here, so I need to multiply to negative 5 and add to 4. Okay, so multiply to negative 5 and add to 4. How about 5 times negative 1 is negative 5, and 5 plus negative 1 is 4. So my factored form is x plus 5 times x minus 1 equals 0. So what value of x makes this factor a 0? That value is negative 5. And what value of x makes this factor equal 0? 1. So negative 5 and 1 are my two solutions. Now let's check that. So if I put a negative 7 here, then I get negative 7 plus 7 is 0. I have an undefined term. Okay? If I put negative 7 here and here, so I have negative 7 times 0. Or if I put a 0 here, so 0 times 0 plus 7 is 0. So I can't have 0 either. Okay, so 0 and negative 7 are no good, but these are not 0 or negative 7, so these solutions are okay. And number 6. I have a p plus 1 and a p minus 1, and then I have a p squared minus 1, but I can factor this. This is a difference of squares, so what that means is p squared is a square number because the square root of p squared is p. 1 is a square number because the square root of 1 is 1. Okay, so I get nice neat square roots for each term, so those are square numbers. And minus means a difference, so I'm doing the difference of two square numbers. Now if I put a 0p in the middle, I would be looking for numbers that multiply to negative 1 and add to 0, and those numbers are 1 and negative 1. Okay, so we can factor a difference of squares quickly by taking the square root of these and writing a pair of conjugates. P plus 1 times p minus 1 is how we factor this difference of squares. Okay, so p plus 1, p minus 1, I already have those here, so I don't need anything more. So p plus 1 cancels here, so I have 2p times p minus 1, which is 2p squared minus 2p. Okay, then here, p minus 1 cancels, so I have 3 times p plus 1, which is 3p plus 3. And here, p plus 1 and p minus 1 cancel, so I have 15 minus p and nothing to multiply it by. Okay, so let's move everything to the left and simplify. So we have 2p squared. Okay, then we have negative 2p plus 3p, which is p, plus p is 2p. And then we have 3 minus 15, that is negative 12. Okay, now when I factor, the first thing I should really look for every time is a GCF, and these three terms have a greatest common factor of 2. So I can factor a 2 out of these three terms and get p squared plus p minus 6 equals 0. Okay, so let's look for numbers that multiply to negative 6 and add to 1. How about 3 and negative 2? 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So I have 2 times p plus 3 times p minus 2 equals 0. So there's no value of p that can make this factor a 0. But negative 3 would make this factor 0, and 2 would make this factor 0. Now let's just check our domain. So a negative 1 would make this a 0. So p can't be negative 1. Positive 1 would make this a 0. Okay, and positive 1 or negative 1 would make this a 0. So negative 1 and positive 1 would have to be thrown out. So I don't have to throw anything out. Okay, now be careful because we didn't throw anything out in this lesson, but you've got to check that domain because there could be a time when you get an answer that violates the domain and you have to throw it out. Maybe the whole answer violates the domain, so there would actually be no solution. So make sure you're checking the domain and watch for solutions that have to be thrown out.